Hertzsprung Russell diagram, or sometimes we say Russell Hertzsprung diagram, HR diagram. So they came up with this graph where we got the temperature of the stars in the x-axis and the power output from the stars in the y-axis. And what we have got is the different stars at different stages in the life cycle of the stars. So these stars are in main sequence. What does that mean? The stars in main sequence, that means they are stable. At the core of the star, hydrogen is fused into helium. So they are in main sequence, and the stars here, I mean, here we have sun. Sun has been there for 5 billion years, and it will stay like that for another 5 billion years. But the stars here, some of them can stay for trillions of years. But the stars here, they are very hot. You can see the temperature is hot, high, and they output lots of power. And because of the size and the mass of the star, the fuel runs out quickly. So what happens is that from this main sequence, once the hydrogen turns into helium from the core, when the hydrogen runs out, they will become giants, the giants, red giants or super red giants. So you can see they are the temperature is low, but the output is a lot. They are kind of equal to the output from these stars. The reason is because they are big, although the temperature is low, but because of the size of the surface area, they're able to output lots of power. That means they are brighter. Size of the core of these giants and supergiants would decide whether that the stars will end up as white dwarfs, or in some cases they will end up as neutron stars and black hole. And they're not mentioned here, but a sun-like star, like a sun-like star, will become a red giant like this, and then later it'll become a white dwarf. So if I draw that, a sun-like star will become a red giant, and after that the core will contract and become a white dwarf, and the outside shells will be expelled and become a planetary nebula. But the huge stars where the will have a supernova, and the rest, the core will become either neutron star or black hole. So a sun-like star will become a red giant, and then it'll become a white dwarf. And white dwarf is cool down. I mean, they are very, very hot, and once they cool down, they will become a black dwarf.